Exam is just a few weeks away and time is limited. Hi, I'm Terry. I've created Express Notes to help you revise additional mathematics quickly and effectively. Today's topic is chapter 2.3, Quadratic Function. Let us get started. The coefficient of x squared determines the shape of the graph. This one I learned in maths, right? More than 0, if your a is more than 0, it's a smiley face. If your a is less than 0, it's a frowny face. Yeah, you all know this, right? Okay, then also again, the b squared minus 4ac concept comes in again. Well, the b squared minus 4ac determine the position of the graph. Now, the first one, if it's more than 0, intersect at 2 points. Provided your a is more than 0, when your a is more than 0, it's a smiley face. If your a is less than 0, it's a frowny face. Okay, this one touches at 1 point, this one also touches at 1 point. For the third one, right, if you have no real root, right, the entire graph lies above. So there's a term for this. They say this graph is always positive. Always positive happens when your a is more than 0 and your b squared minus 4ac is less than 0. Then at the same time, you also have a case of always negative. The graph is always negative if your a is less than 0 and your b squared minus 4ac less than 0. Okay, I know some people, they didn't pay attention. They will still get messed up about this part. When I say the graph is always positive, right? The graph cannot touch the x-axis. When it cannot touch the x-axis, it has no solution. You try to solve it, there's no solution. If you have no solution, meaning it has no real root, your b squared minus 4ac must be less than 0. Okay, I hope you remember this. Okay, so there are two conditions, more than 0 here, and this b squared minus 4ac less than 0 for always positive. For always negative, your a should be less than 0 because it's a frowny face. Now, can I get always positive for this graph? No. Why? If you extend it, part of the graph will cut the x-axis. Yeah, you cannot have a less than 0 and have always negative, always positive. At the same time, you cannot have a more than 0 like this and have always negative, because if you extend it, it will somehow cut the x-axis. Okay, now let's look at one example. Very simple. State whether this graph touches, intersect, or does not intersect the x-axis. We do b squared minus 4ac. Your b is negative 12. I square it. Your a is 9. Your c is 4. So 144 minus 144, this is 0. So we say it touches at 1 point, right? No, you're not supposed to solve it. You're supposed to determine whether this graph touches the x-axis or intersect the x-axis. Yeah. Wait, next one. B squared minus 4ac. My b is 5. My a is negative 2. C is 8. So this is 25 plus 64. Answer 89. More than 0, right? Okay, but this graph is a maximum. It looks like this. Okay, so it will intersect at 2 points. Yeah, intersect the x-axis at 2 points. I don't have to write the x-axis. This one touches the x-axis at 1 point. This one intersects at 2 points. You don't have to draw it. This curve intersect the x-axis at 2 points. Find the range of values of k. Okay, so let's start off by we know that it will intersect at 2 points, right? So we know our b squared minus 4ac should be more than 0. So b is minus 2k. You square it. Your a is k plus 1. Your c is k plus 3. So a bit long here. You need to expand the bracket first. So 4k squared minus 4. Expand this bracket. Ryan, are you okay? K squared plus 4k plus 3 more than 0. Expand the bracket. 4k squared. We expand this 4k squared minus 16k minus 12 more than 0. Can we cancel this too? Cut. Right. So minus 16k more than 12. When you divide them, change the symbol. 12 can divide by 4. 16 can divide by 4. This is 3 over 4. Change the sign. K is less than negative 3 over 4. Okay, remember I talked about always negative just now, right? You can see your a is negative. So, and the whole graph will lie below the x-axis. If that's the case, your b squared minus 4ac should be less than 0. Now your A is already less than 0. So we know it fulfills two conditions. A less than 0, B squared minus 4AC less than 0. Yeah, so the graph will be always negative. Okay, my B is P minus 1. I square it. Minus 4. My A is negative 1. My C is P minus 4. The result less than 0. Let's expand this. P squared minus 2P plus 1. This is plus 4 times in 4P minus 16 less than 0. Okay, you can put them together. This is 2P minus 15 less than 0. Can factorize, right? Okay, what's a factor of 15? 5 and 3, yeah? 5 and 3. So the bigger number is 5. 5 is positive. Smaller number 3 is negative. Let's sketch the graph, right? Using quadratic inequality. The roots are either negative 5 or positive 3. This is positive 3. So less than 0 means the region should be where? Below. Now, please, guys, please don't get confused with this is a B squared minus 4. This is, we're talking about the range of values of P. This graph, I'm drawing the graph of y equals to a function of P, not a function of X. It's a different function altogether. Okay. So it's don't say, Terry, I thought it's always negative. This is for X. This is y equals fx. Right? This is y equals fp, a function of P. Okay. So it's two different graphs, right? Just have to shade the region here. We know in order for this to be less than 0, your P value is between negative 5 and 3. Yeah, if you submit negative 5 and 3, the graph that we draw here should be, entire graph should be below the x-axis. Okay, some of the new KSSM syllabus, they have this thing, the effect of ABC on your quadratic function. Okay, but the good thing is it's something that you probably learn in your mod maths as well. Okay, so okay, let's start with the basic stuff. Okay, if your A is more than 0, like generally, right, your quadratic function is in this form. Okay, if your A more than 0, we know it's a smiley face graph. You know that, right? But the magnitude of A, everyone, if magnitude of A is more than 1, the graph should be, should I say, the width is smaller, or the width decreases. They like to say width decreases. If your A is less than 1, the width increases. Yeah, your A affects the width of the graph, or should I say it curves higher, faster. This one go up faster, right? This one goes up slower. Okay, or we say the graph is broader, right? We can say narrower, broader, but some of the textbook like to use the word width decreases. Sorry, this one, the width decreases. This one, the width increases. Okay, next one. Now, to say that the value of B determines the axis of symmetry, to say the value of B alone determines the axis of symmetry is not true. Your axis of symmetry is dependent on both A and B. Now, I don't know whether you still remember, this is from your mod maths. Axis of symmetry is given by this equation. This is your axis of symmetry. It is given by minus B over 2A. So the value of B alone doesn't affect your axis of symmetry. It depends on your A. For when your A is more than 0 and your B is less than 0, should I put it this way? If your A and B has a different sign, one positive, one negative, is on the right. If the A is positive, B also positive, then your axis of symmetry is on the left. If they have the same sign, it's on the left. Now, similarly, this is A less than 0, right? Look at this. A less than 0, B more than 0. Right? They have different sign. Your axis of symmetry should be on the right. This one, same sign, both negative. Axis of symmetry on the left. Okay, C is the easiest. C is the easiest. C determines the y-intercept. Okay, now not necessarily symmetrical in the middle. For example, let's say I give you 2x plus 3. This one, right? My axis of symmetry is on the left or on the right? You should be able to tell me by now. Left hand side, left. Why? My A and B, they both are positive. Both are positive means same sign. Same sign, left hand side is on the left. And my y-intercept is 3. Because the example that I gave you here has no b. When there's no b, is right in the middle. So that means, for example, y squared plus 1 is very straightforward. We say shift up by 1. Y squared, y is x squared minus 1. We say shift down by 1. Another example, what if this is negative x squared plus 2x minus 3? Okay, tell me, where do I draw it? Left or right? In this case, on the right, because your A is negative, B is positive, different sign. On the right, my axis of symmetry is here. And what's my y-intercept? Okay, wrong with it. My y-intercept should be where? Negative 3. So it should be below. Understand? Okay, let's look at one example. Okay. Okay, so in this is in your textbook, and I think the likelihood for this to come out in SPM, I mean, the chances of it coming out SPM is quite high. This is a new KSSM syllabus type of question. So they give you an original graph, and they are supposed to sketch the graph given that, okay, look at this. Original fx is this. What's the relationship between fx and gx? Gx has a negative in front of your A. Your fx originally is smiley face. The moment you have negative in front, what happened to your graph? The graph is what? Upside down. Right? The graph is upside down. Isn't it? Actually, there's something that I should... Okay, actually, there's a mistake. I want to tell you the mistake is this. The mistake is we tend to draw like this, which is wrong. You know why it's wrong? The C value. The C remains unchanged. Yeah, your C remains unchanged. So if you cut here, you know what I'm talking about? Your C remains unchanged. It's just that your A is inverted. Okay, second one. How about this? Originally, my B, right, is here. Now my B is -4. So -4 means I'm shifting the graph where? To the right. So, but my C remains the same. So the graph still like that. Just shift to the right. Okay. By the way, right here, this is y equals hx. Previous one, I need to write y equals to gx. This is y equals gx. Okay, next. How about part C? Now, what happened to your C here? There's a +1 here. So what should I do? Shift it up by 1. Okay, we can't really show, maybe I just draw like that. This is your C +1. Just show that the C value is higher. The y-intercept is higher. The shape remains the same. This is y equals to kx. Maximum, minimum of a quadratic function. Okay, so now we know that a quadratic function can be written in 3 different forms actually. So this is called the general form, right? This is called the general form. This is called the vertex form. There's another form called it's called intercept form. Actually, I wrote down here. Where is it? Here. General form, intercept form, vertex form. General form is this ax squared bx plus c. Intercept form is x minus alpha beta, right? It actually tells us the x and y, x-intercept. Is another word for this is factor form. We also call it factor form. Okay, and vertex form is the one after you completed the square. Okay, so here's the thing. Coming back to this one, right? When you complete the square, you get vertex form. A vertex form is very helpful because it tells us the minimum or the maximum. The vertex, the vertex is the point, the sharp point of your graph is your Q value, can be minimum, can be maximum. And it happens when the one inside the bracket x minus p is 0, x is p. X equals to p is what we call your axis of symmetry. So again, if your A is more than 0, Q is minimum. If A is less than 0, Q is maximum. Okay, let's look at one example. Very simple. Your Q value is -7. In this case, your A is more than 0, right? Your A is 2. So it has a minimum value of -7 when x is 3. Okay, they say state the maximum or minimum with a corresponding value of x. This is the minimum, maximum. This is the corresponding value of x. Okay, the second one, right, maybe I put the negative in front. There's a x plus 2 squared plus 9. You can see your A is at less than 0. Your gx has a maximum value. Your maximum value is 9. When the one inside the bracket is 0, x is -2. So this is your vertex, and this is your corresponding value of x. So we have a graph of a quadratic function here. It is given such that it intersects the x-axis at 2 points, x equals 1 and 4. The two things you can find from here is that, number one, we can find your axis of symmetry. When it comes to a graph like this, right, quadratic, we can find our maximum point. You will have to find your axis of symmetry, your x value, and your vertex, your y value. So your axis of symmetry is basically the midpoint of your roots. 1 plus 4 divided by 2, your x is 5/2. And your vertex here is y equals to q. Now, next thing is we want to find the maximum, minimum from your quadratic function. You can see your a is less than 0. Your fx has a maximum. And what's my maximum? My maximum is 7. When the one inside the bracket is 0, x is just p. So let's take this and compare with what you have from your graph. Now, from your graph, your maximum or your vertex is q. So q is just 7. And your axis of symmetry is 5/2. So your p is 5/2. Now, I still need to find a value of r. R represent my y-intercept. So we can write this as 0 r. Your x is 0. Your y is r, at the y-intercept here. So, but before we substitute the coordinate, maybe it's best we take our p value, which is 5/2. We put it inside. You square it plus 7. And you want to sub in the coordinate 0 r. So your r is -2. 0 minus 5/2 square plus 7. You can see this calculator, right? Okay. 0 minus 5/2 is 5/2, close bracket, square it, plus 7, 11/2, negative 11/2. So you got your p value, your q value, and your r. In the previous part, we talked about the effect of ABC. Now, A determines the minimum or maximum. We know A more than 0 is minimum, less than 0, maximum. Now, A also, the magnitude A also affects the curvature, or we say the width. For example, if your A has a magnitude that is greater than 1, so like more than 1, so you can see the width actually decreases, or the graph is narrower. Look at the difference between this and this. You see, if this is 1, this is 2, the A here and A here, they're actually the same. It affects the width. If A is more than 1, the width is smaller, or we say the graph is narrower. If A is less than 1, we say that the graph is broader, or the width increases. Okay. Now, remember B, last lesson I mentioned, B actually depends on A actually. The B over A, the negative B over 2A to be exact, it is your axis of symmetry. So it depends on it. You can't exactly say, oh, B affects left and right. It depends on A. If B positive, A positive, then it's on the left, right? If both of them share the same sign, it's on the left-hand side. If both of them has different sign, like B positive, A negative, or B negative, A positive, they're on the right-hand side of the graph, okay? And C represent your y-intercept. But in this case, your P here, normally I put the negative here because it is to show that your fx has a maximum or minimum, or we call it the vertex, is outside the bracket, which is Q. When the one inside the bracket is x is 0, x is P. X equals P is your axis of symmetry, and this is your vertex. You all know that, right? So in this case, your effect of P is that if P actually determines the horizontal movement, either move to the right or move to the left. If your P is increases, yeah, or we say positive, the axis of symmetry is on the right. Okay, for example, this one, your x is 1. Your axis of symmetry originally is at 1. Okay, let me label here is 1. Okay, now the moment you increase it, this one is increased to 5. What happened to your axis of symmetry? Well, your axis of symmetry is now shifted to the right, yeah, by 4 to 5. Now, what if you change this to -2? Your x is now -2. Your axis of symmetry is -2, so the graph is shifted to the left. Your axis of symmetry is now -2. All right, now the next thing is your Q. Q, like I said, is a vertex. Yeah, it determines the vertical movement, vertical motion, it either goes up or down. So it is not your y-intercept. It is not. It's just show us the minimum, can be maximum depending on your A. So you can see the 3 points here. Originally, this is +3, meaning your vertex at 3. The moment you change to +5, this becomes 5 here. Yep. And if you change to -1, it's shifted down to -1 here. Okay. All right. So all these are in the new KSSM syllabus. KBSM doesn't have all these, right? Yep. We can just refer to the book here. Okay. So here in example 24, we're going to draw on 3 separate axes. Yeah. The graph of y equals ax minus b squared plus q. Now they say draw or sketch a graph of y equals fx when a is double. Originally, your a is determines the shape, right? When you double it, what happens? The graph becomes what? Is more than 1. Becomes what? Now, I won't say 1. Maybe originally your a is 2. Double it becomes 4, right? So basically, it becomes what? The graph becomes sharper. Okay, now it's up to you how you want to draw all this. We say the width decreases. The width decreases. Okay, as long as it is inside. Wow, I'm going to draw twice. One on the left, one on the right. Okay, oh, this is still ugly way. Okay, yeah, yeah, yeah. The y-intercept, no, the y-intercept would change actually. You see, unlike the quadratic equation general form, right? In general form, right, your y-intercept doesn't change when you change your a. But this one, your y-intercept will change because q is not your y-intercept. Q is your vertex. So when you increase your a, right, you add to your vertex, your y-intercept is not the same place anymore, right? Okay, it doesn't cut the same point anymore. Okay, my graph for a is done. Okay, the maximum minimum point is the same. This point is the same. Sorry, my graph doesn't really show that this is the same point. It goes up. Yeah. All right. Second one, P increased by 2. Now, originally your P is already on the right. So when you increase by 2, it is now shifted further to the right. So the graph will go like this. Okay. Now you don't have to label this. If you were to label this as P, this would be P plus 2. That's all. You don't have to show the y-intercept because if you were to show the y-intercept, you have to go all the way up, right? So don't need to do that. Yeah. Just show that the graph is now shifted to the right by 2. Okay, next one, Q reduced by 3. Okay, for the next one, Q reduced by 3, I have to shift my graph downwards. Okay, so the graph is now shifted down. Your vertex is now below. Okay, my graph should maintain the same shape. I'm going to maintain the same shape. Sorry if does it look fatter? It's supposed to look the same shape. Yeah. It's a bit hard for me to draw. Okay. Okay, I'll just draw like this. Originally, this is Q. This is now Q minus 3, shifted down by 3. Okay. Now, there are 3 forms of quadratic function. The first one, of course, is the general form. So general form is ax squared plus bx plus c. Now, you've learned that A determines the shape of the graph, maximum, minimum, also the curvature, whether it's the width increases or decreases. B affects on your axis of symmetry. Like I said, B also depends on A, and C affects your y-intercept. Now, we can also write in the second form called the intercept form. Oh, by the way, the ABC here also helps you to determine your B squared minus 4AC, whether intersect 1 point, touches intersect 2 point, touches 1 point, or having no intersection. Now, we can also write in intercept form, or another word for this is called factor form. I think the textbook call it intercept form. Other books, right? I think they call it factor form. Like IGCSE A levels, they call it factor form. SPM, they call it intercept form. It's the same. It's basically represent the x and the y-intercept. But take note that not all quadratic function can be factorized, right? So if you can factorize, yes, it does intersect the x-axis. Some can't. Some will actually intersect the x-axis, but it's not exactly a nice factor. It can be insert form as well. Okay. So the third one is vertex form. Vertex form is basically after you completed the square, right? it looks like this, okay, where Q is the vertex and P is your axis of symmetry. Okay, so how do you go from one form to the other? So if you want to convert to from general form to intercept form, basically you factorize. You convert general form to vertex form by completing the square. And intercept form and vertex form, you can just convert back to general form by expanding the bracket by expansion. Okay, so this is one example relating vertex form with general form. Actually, this is a general form. So it's actually easier to expand than to complete the square. So I'm going to start off with the vertex form here. I'm going to rewrite this as fx equals negative 3x plus n squared plus 7. And I'm going to expand the bracket. So when I expand this bracket, I'll get x squared plus 2nx plus n squared plus 7. Multiply the negative 3 inside, minus 6nx minus 3n squared plus 7, right? And copy the general form here below. Negative 3x squared minus 12x plus m. So to find the values of m and n, which is what we want to do, we just compare this and this. Sum of this and this. So we started by comparing the coefficient of x. The number in front of x is negative 6n, and this is negative 12, n is 2. If you want to find the value of m, compare your constant. My constant m is negative 3n squared plus 7. So put 2 inside. So minus 3 times 4, 12, minus 12 plus 7, m is minus 5. So you got your m and you got your n. Okay, to find the maximum point, what do you do? So which one is more useful to find maximum point? Vertex, huh? Yeah. So now that you got your n and m, right? So let's sub inside your vertex form. Actually, in fact, to be exact, I sub inside here because it's better to put the negative 3 and the bracket in front. My n is 2, right? And this is plus 7. So when you write in this form, you can tell that your a is less than 0, your fx has a maximum, and the maximum value is 7. Now, this is 7. When the one inside the bracket is 0, x is minus 2. So can you write this coordinate? You're supposed to write the coordinate maximum point, right? Maximum point as x followed by y, minus 2 and 7. Okay, come, let's talk about this one. When we complete the square, the idea is to add a number, square, and then minus it up. You all know this, right? Yep. Okay, I'll go straight to one example, right? Example 26. Okay, if the coefficient of x squared is already 1, right? We just have to add half of this number. This number is negative 5. You add half of it, negative 5 over 2. You square it, then you must minus the same number of plus with 3. So the first 3 term, you can combine it into x minus 5 over 2 square. 5 square is 25, 25 over 4 plus 3. So this will give us x minus 5 over 2 square. Okay, and then this will be what? Minus 25 plus 12. Minus 39. 13 over 4. You are supposed to also find the minimum or maximum value of fx. So what's your minimum, maximum? In this case, it's minimum because your a is more than 0, right? Okay, fx will be negative 13 over 4. And that happens when the one inside the bracket is 0, x is 5 over 2. Okay, for b, right? This is negative 2x squared minus 12x plus 7. Let me rearrange first. Put x squared first, followed by x, followed by constant plus. Okay, now next, we need to factorize the negative 2. Now, in the event that coefficient x squared is not 1, we will have to factorize first. Keep the x squared. This one is positive 6x. Keep the 7 outside. Now, 7 is not involved in the process of completing the square, so we just leave it out. Don't do anything. Right? I know some people say, Terry, what if I factorize the 7? I take out negative 2. I write x squared plus 6x minus 7 over 2. Cannot, can. I just don't want to do extra work because I feel it's a bit longer with the fraction. So I'll just leave the 7 outside. Step 2, complete the square. Take half of 6, which is 6 over 2 square minus 6 over 2 square. Now, seriously, I don't want to write this. Yeah, I would write 3. Okay, so it's like making me look stupid, right? So this is x plus 3 square minus 9 plus 7. This is minus 2 x plus 3 square plus 18 plus 7. Answer is negative 2 x plus 3 square plus 25. Okay, we know this is maximum, right? Your a is less than 0. Your gx has a maximum value. My maximum value is 25. When the one inside the bracket 0, x is negative 3. How about this question? You have to complete the square and solve for h and k. So number 1, to complete the square, everyone, you can see that there is a 2. I will need to take out the 2. This is 2. Okay, left with x squared plus hx, close bracket, plus, okay, this is not h anymore. This is what? H over 2x plus 3. So here's the thing. You're going to add a number, okay? So now you tell me, if you use the standard method, am I supposed to write h over 2 over 2? Which is kind of stupid, right? So can I not do that? Can I straight write h over 4? Right? Then you minus h over 4 square plus 3. Now I haven't completed the square yet. When you combine this, it becomes x plus h over 4 square minus h square over 16 plus 3. This will be 2x plus h over 4 square. This will be h square over 8 plus 3. The result will be x plus h over 4 square minus h square over 8 plus 3. Okay, so I've already expressed in this form, right? Now, next, we're supposed to find the value of h and k. Okay, to find h and k, number 1, we need to identify the minimum, maximum. Right, the previous question that I've given you, the minimum maximum value are quite direct. This one is in the whole big expression here, which is what? Minus h squared over 8 plus 3. When the one inside the bracket is 0, x is negative h over 4. So you want to compare this with the minimum, maximum from the graph. Now look at the minimum here. Your axis of symmetry is x equals negative 2. The minimum value is k. So let's compare. K is negative h squared over 8 plus 3. I can't do anything with this. Leave it out. Your axis of symmetry is h over 4. You equate with negative 2. This is negative 2. So h is 8. As we sub inside equation 1, your k is negative 8 squared over 8 plus 3. Negative 8 plus 3, answer k is negative 5. Okay, now my graph by right, perhaps, right, my graph I shouldn't draw like this. Perhaps I should draw my graph a little bit lower, because some of you claim that, hey, Terry, your graph, your k value is negative. Why your k is positive, right? It doesn't matter. Yeah, maybe I should move my graph a bit lower so it makes more sense, right? Yeah, okay. So sometimes you get this kind of answer, then you doubt yourself, hey, am I getting the right answer? Because my k from the graph looks like positive. When you sketch a graph, actually there are 2 types of graph sketching. One is in your ModMaths, we base on the what we call the roots. Like in ModMaths, right, we factorize here. Let's say, for example, your roots is the x is 1, and let's say 5. Then you find your axis of symmetry, right? X equals to 1 plus 5 over 2, you get 3. Take this, you sub inside your fx, then you get your y value, right? Okay, so that is ModMaths. But at Maths now, we are going to use vertex form. This is your vertex form. We of course we find the minimum, maximum first, right? And then we sketch a graph. Now, not all graph will actually intercept the x-axis. Sometimes you get like a function fx equals to 2x minus 1 squared plus 3. If you go and find the x-intercept, you will you will get math error. Like for example, some people say, oh, Terry, I go and find this at x-axis, y0, I put 0 here, 2x minus 1 square plus 3. I bring my 3 over, I get negative 3 over 2. And then I square root this, I go plus minus negative 3 over 2, right? Then I go and type in my calculator. Can't see this calculator. You can see this one, right? I type in my calculator, I go and put square root negative 3 over 2. What do you get? Math error. Obviously, you get math error because there's no intersection, right? There's no solution. So not all graph would cut the x-axis, right? Another example would be a maximum graph like this. You may have a maximum graph, the entire graph falls below the x-axis, right? So there's no intersection. There's no need to find the intersection of the x-axis. Yeah. If there is sometimes we don't have any. All right. Intersection y-axis, we definitely have. You have to find it and you draw a graph. Sometimes you may have to find the corresponding range. Sometimes they'll give you a domain, you have to find the range. Okay, let me show you one example. There are two graphs here we have to draw. The first one is the one that does not involve any intersection x-axis. So we know from here, right, your a is more than 0. Your y has a minimum value. What's the minimum? My minimum is 5. When the one inside the bracket is 0, x is negative 3. So we draw the graph, shift to the left by 3, shift up by 5. So, sorry, I do freehand, sometimes very ugly. Okay, negative 3, positive 5. This is the minimum. If it's the maximum, the graph looks like this. This is a maximum, but we want to draw a minimum. So it should be coming down, going up. Yeah, intersect here. All right. They do ask you to draw quadratic graph, right? Yeah, they can. Came out a few times in SPM, so you need to know how to draw. I think quadratic graph is more likely. Trigo graph is a certainty. They definitely ask you to draw trigo graph. Quadratic, yes, more likely compared to the B modulus graph. Okay. Now, do you have any intersection the x-axis? No, so you don't have to find. Y-axis, yes. So we say at y-axis, your x equals 0. Let's put 0 inside your function here. Put 0 here. Your y will be 2, 0 plus 3 squared plus 5. 3 squared, 9, 9 times 2 is 18. 18 plus 5, 23. There you go. That's your graph. Yeah. Okay, now, the next thing is, if you want to find, if you want to draw the graph, maybe I put negative 3 in front, x minus 1, 12 outside. We know for sure this is a maximum. Your a is less than 0. My y has a maximum value of 12, and that happens when x is 1. Okay, so it's 1 to the right, 12 up, and it's a maximum. So let me do a sketch. Oops. Sorry, my line is not very straight. So here, this is 1. This is 12, and it's a maximum. It's a minimum, it's a maximum. So the graph should go up. Touches 1 point, come back down. Okay, this part is a bit ugly. Let me just adjust it. Okay, not too bad. Now, does it cut the x-axis? In this case, yes. Does it cut the y-axis? Yes, certainly. Yeah. So we know at x-axis, your y is 0, right? Let my y be 0. Okay, so you have 12 minus 3x minus 1 square equals 0. 12 equals to 3x minus 1 square. You divide this, 12 divided by 3 is 4. Whenever you square root, there is a plus minus. Your x is minus 12, sorry, minus 2 plus 1. Minus 1, positive 2 plus 1, positive 3. This is minus 1 and 3. Okay, I just define my y-intercept. I know at y-axis, x is 0. Let x be 0. My y will be 12 minus 3, 0 minus 1 square. 12 minus 3 is 9. There you go. My graph is done. Okay. We're supposed to complete the square and express in this form. Yeah, you can see the coefficient of x squared is 2. So we're going to start off by factorizing the 2. Take out the 2, left with x squared. This is 5 over 2x, close bracket, minus 7. Right? Remember, you cannot complete the square unless your coefficient x squared is 1. If it's not 1, we factorize them. Okay, number 2, I'm going to add the number. What is the number I'm going to add? The number must be half of this. So we're going to add negative 5 over 2 over 2. Negative 5 over 2 divided by 2 is 5 over 4. We square it, then we minus it off, right? Close the bracket, and then minus 7. Now, remember, the first three terms can be combined together, becomes a bracket. This is a 2, this is a 2 here, with a bracket x minus 5 over 4 square. 5 square is 25, 4 square is 16, minus 7. Yeah, remember, always keep the 7 outside because it's not involved in the process of completing the square. Now, let's multiply the 2 inside. 5 over 4 square. This will be 25 over 8. 16 and 2 can cancel. Minus 7. Right. This is not a nice number, right? 56, 81. Is it 81? 81 over 8. Okay. Now, let's identify the minimum maximum. Actually, I've done part A already. I already expressed in this form, but they're not nice number, right? So the minimum value is the one outside, which is 81 over 4. When the one inside the bracket 0, x is 5 over 4. Yeah, remember the process of completing a square, the number here that we add must be half of your coefficient of x. If there is a negative here, please add in a negative. It's basically negative 5 over 2 divided by 2. So I just don't want to write so many steps. Do you want to write this? Do you prefer to write this, or do you prefer to write negative 5 over 2 over 2? Can we just write negative 5 over 4? Isn't this harder to write? Right? So the constant is always half of it. There is no, one is a plus, one is a minus. Remember, we add this number so that, we add this number here so that 1, 2, 3 can combine to this. But you're going to subtract it off to balance out the equation, because otherwise you're creating an additional term in the value. You see, when you go and cancel this, right? Not that you should always get back the same thing as above, right? But we add this so that we add this term here so that we can combine this 3 into a bracket square and maintain this outside. Okay. All right. Now let us sketch a graph. Okay, we know it's a minimum, right? And we know minimum is at negative 81 over 4. Now, actually, I in my opinion, it's actually easier to draw the graph and draw axis later. Because I know you guys have been trained to you draw this first. It's actually quite hard to draw this first and trying to make sure it passes through all the points. It's actually quite difficult. It's actually, on the other hand, it's actually easier to sketch this first and label the rest later. Okay, my graph looks like a Nike sign, right? Okay, I'm gonna add like this because I know it's going to have an x-intercept, a y-intercept, and I'm supposed to draw from -1 to 5. Okay, you can draw a bit longer. I just rub it out because I don't draw too many times. Did I write only 81 over 8? 81 over... Okay, sorry, I wrote this wrongly. 81 over 8. Thank you, Benjamin. 81 over 8. Sorry, I made a mistake here. 81 over 8, right? So this negative 81 over 8 is my minimum, and my corresponding x value is 5 4. Sorry, it's a bit ugly. And we have to find the x-intercept and the y-intercept. Okay, because in this case, it's actually easier to find the x-intercept from here. You can let your y or fx be 0, solve for this, right? You can, but I think for this case, right, I will just use back from here. At x-axis, your y is 0. Sorry, since my graph I already used a lot of space, right? So I'm going to use here at x-axis y 0, right? My y is 2x squared minus 5x minus 7. Can we factorize this? What is your factor? 7. This should be a 7 and 1, right? Minus and plus. The roots are 7 over 2 and negative 1. Meaning, this is my negative 1 here. This will be my 7 over 2. Right? Remember, the roots represent the x-intercept. Now, you know why I don't want to extend this higher? Because the question asks us to draw from -1 to 5. So I stop there. No need to draw any higher, right? And one more thing. Okay, 2 things. 1, y-axis X is 0. Let us put 0 inside here and here. My Y should be what? -7. Guys, you know what I'm talking about. I'm putting 0 inside here. This one automatically becomes 0. I get -7, right? So this is -7. Okay, what else? This is 5, right? We need to put 5 inside. When X equals to 5, put 5 inside. Now, whether you want to put inside this vertex form or your general form is fine, whichever. So this is 5/2 square 5/2 minus 7. Sorry, very ugly. Use your calculator. This will be 2 5/2 square minus 5 times 5/2. Then you minus 7. You should get -7. Hey, wait. Did I make a mistake? I'm supposed to put, sorry, not 5/2. 5. I'm sorry, I put in the wrong figure. 5. 5/2 we know is the x-intercept. We're supposed to put 5 inside. Sorry. This is your 5. Just change this to 5. This one is also 5. Okay, what do you get? 18, right? So meaning this is 18 when your x value is 5. Because you're drawing from -1 to 5. Lastly, find the range. Range means your y value. Remember, domain is your x value. I'm drawing from -1 to 5 for my x value. My y value will be from smallest value is -81/8. Largest value is 18. Okay, so we say your range is -81/8. And the graph, you can write fx, you can write y. Maybe up to you. We can write y, fx, up to you. Fx also can, y also can. There you go. That is your range. Okay. The last question from this chapter is the idea of reflection in x-axis and y-axis. So whenever you have a quadratic function, generally you can see this is a quadratic function with a minimum, right? When you reflect in the x-axis, the whole graph is now turned upside down. So basically your y, right, before this you have a minimum, it now has a maximum. Now, how do you make it maximum? By putting a negative in front, you make your coefficient x squared, your a becomes negative, right? So it's upside down. And number 2, before this, your minimum value, I purposely put a negative q here. When you add in a negative in front, it becomes positive q. Can you see? The maximum is now q. But when you reflect in the x-axis, on the other hand, right, x-axis, it doesn't go upside down. In fact, it goes from left to right. Like for example, here you can see your axis of symmetry initially is x equals to p. When you reflect in the y-axis, right? In this case, you reflect on the y-axis, it goes to the other side. So sorry, my graph looks very ugly. It goes like that. Oops. Okay. Too sharp here. This is now x equals -p. You can see from here. So basically what actually changes is your axis of symmetry. Before this is x equals to p, right? Now becomes x equals to -p. All right, let's do one example, okay? Example number 30. Okay, so in this example, everyone, the first few parts are all the same. We have done this before. We're supposed to find an expression for fx in this form. So for me, I will, okay, let me start from here because I need a bit more space. I will take fx and write it as, write the maximum value. I know it's maximum because based on the graph is maximum here. And what's your maximum from here? Your maximum value is q when the one inside the bracket is 0, x is -p. Everyone, this is x equals to 1. This is now your y value. Your y is 8. So you can see that your maximum value is q. Q is 8. Now, at the same time, your axis of symmetry is x equals 1, right? Your -p is now 1. P is now -1. Okay. Now I got my x, I got my p, I got my q. Now let us take these two values, sub inside. Why must I sub inside? Because I need to find my a value. My p is -1. So I put a -1 here. Square q is 8. I want to find a. Now, remember, you need to use another point given. I can't use this 1, 8. Because if you sub 1, 8, this is the problem. 8 equals a 1 minus 1 square plus 8. Then you get this problem. 8 equals a times 0 plus 8. 8 equals to 8. Like, what the hell? What happened to my a? Right? You can't do this. You have to take another given point. Now, notice you're given another point. What is another point? Q. So you have to sub in q minus 3, 0. Right? So as you sub in, your fx or your y is 0. Your x is -3 minus 1 square plus 8. So this is 16. Minus 3 minus 1 is -4. -4 square is 16a plus 8. 16a is -8. A is -1/2. Right? So it's very long. I finally got my equation here. This is the equation of fx in vertex form. Yeah, previously we just compare and find the value of p and q. Now we go one step further to find the value of a. Okay, on top of that, we're supposed to find the equation of curve when it is reflected in the x-axis. Now, just now we talked about that, right? Reflection in the x-axis. When you reflect in the x-axis, what happened to the graph? The graph goes upside down. But basically, we can turn it, right, to that equation by adding a negative in front. So see, everybody, I times negative in front, this one becomes positive. When you times this 8 with negative, it becomes -8. There you go. This is the new equation. You can write fx up. But since the question says equation, you just write y. Yeah. If the question says gx, then you write gx. Okay. Lastly, the solution to this inequality. Okay, for part C, I have two ways to show you, two different methods to show you. Method 1 is the standard method. Yeah, most of you probably are more familiar with this. You take -12 x minus 1 square plus 8 more than 0. This is my fx. Right. Number 2, you don't like negative, right? What do I do? Multiply by -2. Whenever you times and divide with negative, what happened to the symbol here? The symbol has to change, right? Okay, now rather than expanding and factorizing, can I show you another way? We know 16 is what? What is 16? 16 is 4 square, right? Hello? 16 is 4 square. So this is in the form of a square minus b square. When we factorize, we get a plus b, a minus b. If you want to expand and then factorize, go ahead. But I think I will do it this way. It's the same. If you expand, factorize, you still get this x plus 3, x minus 5. Less than 0, right? Okay, so how do you solve this inequality? We sketch a graph. Remember, this is a minimum graph. -3, +5. Less than 0 means where's the region? Below, in between, right? So how do you write our final answer? Let me move up a bit. Your x should be between -3 and 5. Okay, I have another method, method 2. So in my method 2, right, because you know this fx is my graph. This is my graph of fx. Which part of the graph is more than 0? We know this part of the graph is more than 0. I just have to find the corresponding values of x. I just need to find my x value. Now the problem is, I know this x value is -3. I just do not know this x value. Now, we can call this x value as alpha. What is the relationship between -3x and alpha? We use what? What is that? 3 words. Start with letter A. Axis of symmetry. We say -3 plus alpha divided by 2 is what? Is 1. So -3 plus alpha is 2. Alpha is 5. So I know this alpha is 5. Now, from the graph, we can see what? The region of the graph for which the whole graph, the y value or your fx is positive, is here. Right? I really highlighted for you. Let me highlight once again. This is the y value. So this is actually arrow, guys. This is not shading, it's arrow. I'm drawing my arrow downwards to find what are my x value when my y value is more than 0. So I can see my x value is between -3 and 5. So typically this is 2 marks question because since the graph is already given, right? So we don't really need to use method 1 to draw the graph again, right? But if you want to use method 1, no problem. Yeah, method 2 is faster, but you need to find this y value from the graph, which is this x value, the roots, which we can use axisymmetry to find. If this video helped you, you can get my advanced book from Shopee or Lazada or by searching Taliti. For full step-by-step learning, check out my e-course or join my classes at Pusat Tuition Taliti. Remember to like, subscribe, and share. See you in the next video.